ENAUTO Section 6 Summary Challenge, Day 0 Provisioning with Cisco iOS XE software. Match each of the boot mode options to its definition. All right. Configures a timeout in seconds for IPXE. So this is the IPXE question exclusively. Configures a timeout in seconds for IPXE network boot using the IPXE timeout ROM monitor variable. When the timeout expires, the device boot is activated. Device boot in this case means that the device will boot the local image, which is stored on the device. And this is very straightforward. It is, of course, IPXE timeout. All right. Boots through IPXE network boot. The device sends the HTTP request forever, hence the answer, when the boot IPXE forever command is configured. So if one word forever was not enough to hint to the correct answer, there is another one. So anyway, this boot is an IPXE only boot, and that means, of course, that the device will not be loading its local available iOS image at all. So it will only try to boot from the network, from IPXE forever. And of course, device is the last option, and that's basically when device does not try to load image from the network. It will only boot its local one. Which ROM monitor variable should be configured for IPXE to function? So as we have seen on the first screen, there are basically three options. One option is device, which means IPXE is disabled, so it would not function. Another one is IPXE timeout, it will function, but timeout. And the third one is IPXE forever. All right. Cisco Network Plug and Play element to its description. So Cisco Network Plug and Play uses the controller, right? It basically enables enrollment of a device to the controller. Okay, so and this is element. Okay, a central server that encodes the logic of managing and distributing deployment information, images, configurations, files, and instances for devices that are being deployed. So that should be this server, right? Plug and play server, I guess. An open standard protocol, Cisco Network Plug and Play protocol. Okay, I kind of didn't know it's open standard. I kind of assumed it's Cisco specific, but yeah, maybe it's even open. We'll double check that. Okay, it helps configure Cisco devices with a bootstrap configuration and triggers remote branch deployments. Remote branch deployments and trigger devices with bootstrap configuration. This is agent, right? That's what agent does. Bootstrap configuration, and then the Open Cisco Network Plug and Play agent is an embedded software component on Cisco devices. So this is what this option is actually. So this is agent. Yeah, that's probably for the iOS. We'll get back there anyway. It redirects the Cisco Network Plug and Play agent to the correct server after the device boots up. That's probably cloud services, right? And then this option is also should be correct. That's the mobile application for a mobile phone, and it also utilizes a special cable, and of course it's different for iOS and for Android. Until we have like Type-C standardized fully for all platforms. So yeah, and that's basically, it is used when a specific configuration is needed for the local device in order to be able to access the internet, such as MPLS or something like that. So, and then this configuration can be preloaded through a mobile phone, through the special cable onto the device. Okay, I hope this is correct. Which DHCP option code does Cisco Network Plug and Play use to initiate the process? So I only see one familiar option out of these, and it is option 43. Right, so option 43. Yeah, so option 43, this is Cisco Network Plug and Play, and this is the option which utilizes the controller, right? And option 43 basically carries the IP address of the controller in order for the device to be able to reach out to the controller and say hi to it, and then for this device to be claimable from the controller side. All right, which day zero provisioning option uses netboot? Ooh. Well, I think it's IPXE, if I'm not confusing netboot with anything else. It's IPXE, right? Because that's basically loading of a file from the network. ZTP is different. It downloads a Python script, and then Python script executes locally. And of course, it could do all kinds of crazy things if they are needed, all kinds of customization and stuff. This one, Cisco Network Plug and Play, it only enables device to be enrolled into the controller and provisioned this way. So netboot is IPXE. Which two protocols are used in ZTP to download the Python script? They are HTTP and TFTP. Only these two options are supported, and they are configured differently. So TFTP actually uses two DHCP options. One option is number 150. It indicates the IP address of TFTP server, right? And then another one, which is option 67, it specifies the path to the file on the TFTP server, but of course not including the address of the server itself. So that's how it works for TFTP. For HTTP, it's different. It does not use option 150 at all. It only uses option 67, the second one, which is called boot file name. And for the value, it carries the full URL for this file, including the protocol like HTTP : / and then the IP address of the server, and then the full path to the file. Okay, and question 7, match the Cisco Network Plug and Play workflow step with its definition. Oh, all right, so that's basically now from the controller perspective, right? This step is where IP address pools and site-specific settings like credentials, DNS, and blah, 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 defined in DNS Center, and network profile is defined in Cisco DNS Center also, which includes the design of the network device functions and their internal network connectivity. Finally, the network profile is mapped to one or more sites. The site hierarchy is also defined in the face. This is design, right? Of course, it's pretty straightforward. And then the next step, I hope they are in order. Once the device is connected to the network, it uses Cisco Network Plug and Play to discover the Cisco DNS Center controller, saying hi to it, and assigns the device to a site. So I would say that the device discovers the controller, but then controller actually assigns the device to a site. And before, well, or actually it is the same step. Right? So, and controller assigns a device to a site by claiming this device. So device has been claimed to a site within the DNS center. And of course, the last step is provisioning, is basically configuring device with specific settings and applying them. Places device-specific settings, like interfaces, and once the device are up, the network device uses plug and play to obtain the configuration. That's weird a little bit. This step places device-specific settings. And I thought that that's kind of end of it, right? So it's then the device comes to production. But it's a little bit confusing second part here. Once the device, the services are up, the network device uses Cisco network plug and play again to obtain the configuration. Does it use plug and play to obtain the configuration at all? It doesn't, right? Maybe there is some continuation to it, but okay, maybe I missed something, but this is the only logical way to put these options in. Okay, match the new device provisioning day of operations with its definition. Device onboarding, service provisioning, and monitoring analytics. Very easy. Device onboarding is day 0, so device hasn't started working yet, right? So, and then day 1, service provisioning, and then day 2, monitoring analytics, and this day 2 kind of continues on and on until probably some changes, some upgrades. Yeah. So the core, I guess, like kind of key to this answer is also this word here, device, and this word here, service, right? So once device onboarded, it kind of is there. We have control of it. We can do things with it. We can configure it, but it hasn't started working yet. Once we provision a service on the device and start this service, the device actually kind of properly comes into production, and that counts as day 1. All right, this is the last question. Let's see.